Picture this, you're stuck in Mumbai traffic, watching the clock tick as your 2-hour journey across the harbour stretches into eternity. Now imagine crossing that same distance in just 15 minutes, gliding 50 meters above the waves on what locals call a highway in the sky. This isn't science fiction, it's the Atal Setu, and it's rewriting the rules of urban connectivity in one of the world's most congested cities. But here's what makes this story fascinating. A bridge that took decades to dream, years to build, and cost over $2 billion. Yet in its first year of operation, it's carrying less than half the traffic engineers predicted. So what's really happening on India's longest sea bridge? The story begins in the 1960s, when urban planners looked at Mumbai's geography and saw a problem that would only get worse. The city sits on a narrow peninsula, connected to the mainland by a handful of bridges and causeways that were already showing strain. As Mumbai's population exploded, these choke points became economic arteries under pressure. The concept was simple: build a direct sea crossing to Navi Mumbai, the planned satellite city across Fane Creek. But simple concepts often hide complex realities. For nearly 4 decades, what we now know as the Atal Setu, officially the Mumbai Trans Harbour Link, remained just that, a concept bouncing between government departments, facing political changes, funding challenges, and engineering uncertainties. The breakthrough came in 2004 when the Maharashtra State Road Development Corporation took charge, but even then, progress crawled. Political disputes derailed the project in 2005 when competing business groups submitted failed bids. It wasn't until 2011 that the Mumbai Metropolitan Region Development Authority stepped in with a clear vision and, crucially, international funding. Here's where the story gets interesting. Japan stepped in as a partner, not just with money, but with expertise. The Japan International Cooperation Agency provided 85% of the funding, approximately $1.8 billion, through yen-denominated loans at favorable rates, recognizing that this wasn't just an Indian infrastructure project, but a test case for advanced engineering in challenging marine environments. Prime Minister Narendra Modi laid the foundation stone in December 2016, and the project finally had the political backing it needed. But by then, Mumbai's traffic had grown exponentially, making the bridge not just desirable but essential. When construction began in April 2018, engineers faced a challenge that would test every assumption about marine construction. The Fane Creek isn't just water, it's a complex ecosystem with tidal variations, monsoon fury, and depths reaching 47 meters in some sections. The numbers tell the story of ambition: 21.8 kilometers total length, with 16.5 kilometers stretching over water. To put that in perspective, the sea span alone could accommodate the entire Golden Gate Bridge 6 times over with room to spare. But length was just the beginning of the engineering puzzle. Consider the foundation work alone. Engineers drove 1,089 piers into the seabed, with the deepest foundations reaching 47 meters below the surface using reverse circulation drilling techniques. That's deeper than a 15-story building is tall, anchored in marine clay and rock that required specialized equipment. Each pier had to withstand not just the bridge's weight, but the lateral forces of wind, waves, and seismic activity. The construction strategy revealed the project's international DNA. Rather than building everything on site, over 90% of the bridge segments were prefabricated in factories across 4 countries: Japan, Vietnam, Taiwan, and Myanmar. These massive concrete segments, some weighing hundreds of tons, were shipped to Mumbai and assembled using automated girder launchers, a first for Indian infrastructure. But here's what makes the engineering truly remarkable. The bridge had to be built around Mumbai's existing infrastructure. The approach near Surrey required careful coordination with the Bhabha Atomic Research Centre, one of India's most sensitive nuclear facilities. Security clearances, noise restrictions, and safety protocols added layers of complexity that engineers had never encountered. The monsoon presented another challenge entirely. For 4 months each year, construction in the creek essentially stopped as waves reached heights of 3 to 4 meters, making marine work impossible. This seasonal rhythm meant that every construction season was precious, and delays could cascade across years. What you see when you drive across the Atal Setu is impressive: 6 lanes of smooth highway suspended above the waves. What you don't see is the technological ecosystem that makes it possible. Start with the materials. 165,000 tons of reinforced steel and 96,250 tons of structural steel went into the bridge. That's equivalent to 4 Howrah bridges worth of steel, but engineered for a completely different environment. Every piece of steel received specialized polyurethane and epoxy coatings to resist the corrosive salt air that destroys conventional materials within years. The bridge incorporates 830,000 cubic meters of concrete, but this isn't ordinary concrete. The mix was specifically designed for marine environments with salt-resistant additives that prevent seawater penetration and extend the structure's life to over 100 years. In a city where infrastructure often struggles to last decades, this represents a fundamental shift in thinking. But the real innovation lies in the bridge's intelligent systems. The automated traffic management system monitors every vehicle, tracking speed violations, incidents, and traffic flow in real time. High-definition cameras provide 24/7 surveillance, while emergency call boxes every few hundred meters ensure that help is never far away. The tolling system represents another technological leap. India's first open road tolling on a sea bridge allows vehicles to pay without stopping, using FASTag technology that reads transponders at speeds up to 100 kilometers per hour. Cars pay 200 rupees for a one-way journey, 300 rupees for a return trip, rates reduced from higher initial levels to encourage adoption, with substantial discounts for local residents through monthly passes. Perhaps most impressive is what you can't see, the bridge's seismic engineering. Designed to withstand earthquakes up to 6.5 magnitude, the structure incorporates flexible joints and damping systems that allow it to move with seismic forces rather than resist them. In a region where earthquake risk is real, this engineering represents the difference between resilience and catastrophe. Building a 21.8-kilometer bridge across an active marine ecosystem required environmental engineering as sophisticated as the structural work. The Fane Creek supports mangrove forests, migratory birds, and fishing communities that have depended on these waters for generations. The environmental impact was significant but carefully managed. Construction affected 1,635 trees, with 753 removed and over 2,800 replanted in Vasai and other locations. More challenging was the displacement of 320 structures, mostly informal settlements and small temples around Surrey. The project affected 282 families directly, requiring a comprehensive resettlement program that provided 1,540 new housing units in Bhakti Park, Wadala. The fishing community faced particular challenges. Construction activities increased water turbidity, removed traditional fishing stakes, and restricted access to productive fishing areas. Studies showed a 10% reduction in fish catches in areas shadowed by bridge piers, affecting approximately 1,500 fishermen. The response was a 380 crore rupee compensation package, including 5,68,000 one-time payments to each affected fisher, along with alternative livelihood training programs. But the project also created environmental benefits. 335 crore rupees environmental fund supports mangrove restoration at 5 times the destroyed area. The bridge includes 6 kilometers of noise and vision barriers, covering 30% of the structure, protecting both flamingo habitats and screening sensitive areas like the Atomic Research Center from traffic. A birdwatching platform constructed from the temporary access bridge provides new opportunities for ecotourism. The Japan International Cooperation Agency's oversight ensured compliance with international environmental standards, including India's right to fair compensation and transparency in Land Acquisition Act. Grievance redress committees provided ongoing forums for community concerns, earning the project a sustainability certification from the Bombay Natural History Society. 1 year after opening, the Atal Setu presents a fascinating case study in the gap between engineering ambition and user behavior. The bridge was designed to handle 70,000 vehicles daily, but actual traffic averaged 22,689 vehicles per day in its first year, processing 8.3 million vehicles total from January 2024 to January 2025, with peak daily traffic hitting 61,807 shortly after opening. This isn't necessarily a failure, it's a lesson in infrastructure adoption. The bridge's primary benefit isn't just speed, it's reliability. While the journey time has dropped from up to 2 hours to 15 to 20 minutes, the real value lies in predictability. Commuters know they can cross the harbour in consistent time, regardless of traffic conditions on traditional routes. The economic impact extends beyond individual commutes. The bridge provides direct access to the Jawaharlal Nehru Port Trust, India's largest container port, reducing logistics costs by 20 to 30% for businesses across the region. The newly inaugurated Navi Mumbai International Airport, which opened in October 2025 with commercial flights beginning in December, will benefit enormously from this connectivity through the upcoming Ulwi Coastal Road connection. Real estate markets have already responded dramatically. Property values in areas like Ulwe, Panvel, and Kargar have increased by 15 to 25% as these locations become viable for Mumbai commuters. The bridge is essentially expanding Mumbai's economic geography, allowing the city to grow eastward rather than just northward. The toll revenue model reflects long-term thinking. The Mumbai Metropolitan Region Development Authority will collect tolls until 2045, projecting 500 to 600 crore rupees annually to maintain the bridge and fund future infrastructure. As of October 2025, traffic has steadily grown toward 25,000 to 30,000 daily vehicles, and with the airport's recent inauguration, the bridge's full economic impact is just beginning to unfold. The Atal Setu represents more than infrastructure. It's a statement about India's engineering capabilities and urban planning vision. The project demonstrates that Indian engineers, working with international partners, can deliver world-class infrastructure on schedule and within budget, despite challenges like COVID-19 disruptions. But perhaps the most important lesson lies in what the bridge enables rather than what it is. By connecting Mumbai to Navi Mumbai efficiently, the bridge supports the development of a true metropolitan region rather than a single overcrowded city. It provides a template for how coastal cities can expand sustainably, using marine engineering to overcome geographical constraints. The bridge also showcases the potential of international cooperation in infrastructure development. Japan's involvement brought not just funding but technology transfer, like orthotropic steel deck construction, environmental standards, and project management expertise that will benefit future Indian projects. Looking ahead, the Atal Setu is just the beginning. The planned 4.5-kilometer Surrey-Worli connector, currently 70% complete and due in 2026, will link to the Bandra-Worli Sea Link, creating a comprehensive network of sea bridges that will fundamentally change how Mumbai functions as a city. As Mumbai continues to grow, the Atal Setu stands as proof that the city's future lies not in accepting geographical limitations, but in engineering solutions that expand what's possible. In a nation building infrastructure at unprecedented scale, this bridge over the Fane Creek represents both achievement and aspiration, a highway to India's urban future, named for a leader who believed in the power of infrastructure to transform lives. What do you think about the Atal Setu's impact on Mumbai's future? Drop a comment below and share your thoughts on how mega infrastructure projects like this are reshaping cities. If you enjoyed diving deep into the engineering and economics behind one of the world's most impressive sea bridges, hit that like button. It really helps us bring you more stories about the incredible builds shaping our world. And don't forget to subscribe and ring the notification bell so you never miss our latest explorations of humanity's most ambitious construction projects. Until next time, keep looking up at what humans can achieve when engineering meets ambition. Thanks for watching.